I'd like to talk to you today about oxidation numbers. Now, for our purposes, oxidation numbers are also called oxidation states. When we're talking about oxidation numbers and oxidation states, we mean the same thing. Why do we need to know about oxidation states? Well, they help us work out what's been oxidized and what's been reduced in a reaction, and it makes it much easier to be able to work out which is which if you understand them. To be able to do this, it's also helpful to know about electron transfer and oxidation and reduction. One way to help you remember this is to use a mnemonic like Leo says Gur. Leo, loss of electrons is oxidation, says Gur, gain of electrons is reduction. When we assign oxidation numbers, there are a series of rules that we can use. And it's quite helpful to know these rules off by heart. So the first one is, if you've got an element, all the atoms in that element have oxidation numbers or oxidation states that equal 0. So if we take a look at these elements, magnesium in its elemental form is just Mg. So each Mg atom has an oxidation state of 0. When hydrogen is in its elemental form, it takes the form H2. It's a molecule with 2 hydrogen atoms in it. But again, each of those hydrogen atoms has an oxidation state of 0. Sulfur usually exists as a molecule of S2. So once again, each sulfur atom has an oxidation state of 0 because they are elements. Second rule could be that the oxidation number of an atom in a simple ion is equal to the charge on that ion. We call those ions monatomic ions. Mono meaning one, atomic meaning atom. So if you've got Na+, Na has an oxidation state of +1 in this ion. With the chloride ion, 1- charge on it, its oxidation state is -1. Aluminium ions are 3+, so they have an oxidation state of +3. Third rule we can look at is for oxygen atoms. Oxygen atoms in a compound usually have an oxidation number of -2. So if we look at a molecule like CO2, it's got 2 oxygen atoms. Each oxygen atom has an oxidation number of -2. Here, with sulfuric acid, H2SO4, with 4 oxygen atoms, again, each of the oxygen atoms have an oxidation state of -2. There are exceptions to this rule, and one of the exceptions is in peroxides. So peroxides, like hydrogen peroxide, H2O2, oxygen has an oxidation state of -1. Why does oxygen have that -1? Oxidation state? It's because hydrogen peroxide is electrically neutral. Each hydrogen has an oxidation state of +1, so because there are 2 hydrogens and 2 oxygens, that means each oxygen must have an oxidation state of -1 as well to balance out, give us an overall charge that adds to 0. Another exception for oxygen is when oxygen is bound to fluorine in, say, an F2O, which can be written as OF2, depending on which textbook you read. The difference here with the oxygen difluoride is that fluorine is more electronegative than oxygen, and it has an oxidation state of -1. Because there are 2 fluorines and 1 oxygen, the oxygen in this molecule has to have an oxidation state of +2 to give us an overall electrically neutral molecule. When we look at hydrogen, hydrogen atoms in a compound have an oxidation number of +1. So we can look at some examples. Water is a very common hydrogen-based molecule. It has 2 hydrogen atoms. Each hydrogen atom has an oxidation state of +1. In methane, CH4, again, the hydrogens have an oxidation state of +1, so the carbon is -4 in this situation. If we have a look at an exception, There are often exceptions in the rules in chemistry. Hydrogen in the metal hydrides has an oxidation state of -1. So for example, in sodium hydride, the sodium ion has formed, which is Na+, which means that hydrogen, to add to 0, has to be -1. Just a little bit of chemistry humour here. Right, okay, moving on. Number 5, the sum of the oxidation states in a compound is 0. If the compound is electrically neutral, all of the oxidation states have to add up to 0. So we looked at carbon dioxide before, and each oxygen atom has an oxidation state of -2. There's 2 of them there. So in this situation, carbon must have an oxidation state of +4. Another example, H2SO4. In this situation, remember we had 4 hydrogens, 4 oxygens, and each oxygen has an oxidation state of +2. We have 2 hydrogens, and each hydrogen has an oxidation state of +1. So the hydrogens in total give us a +2, and the oxygens -8. Now overall, H2SO4 is electrically neutral. So what is sulfur going to have as its oxidation state? That's right, it's got to be +6. There's only 1 sulfur atom, and we need 6 positives to take this compound to 0. If, however, you do have a charge on the substance that you're looking at in terms of oxidation numbers, then the oxidation states have to add up to whatever the charge is on the ion. Usually this happens with polyatomic ions, poly meaning many, and atomic atoms, so it'd be in ions that have more than one type of atom in them. For example, permanganate, MnO4-. Now this ion has a -1 charge. So the oxidation states of the manganese and oxygen have to add up to -1. Since we know oxygen has an oxidation state of -2 in a compound, we can calculate the oxidation state of manganese in this ion, where oxygen gives us a total charge of -8, and manganese must therefore, to give us an overall charge of -1, be +7. There's one more rule that is quite useful to know, although it's not on the New Zealand list of assigning rules, and this is fluoride. Fluoride is the most electronegative atom on the periodic table, so it tends to just have the oxidation state of -1. It's always -1. So for example, in our oxygen difluoride, which we've already looked at before, we've got F, fluorine again, which has an oxidation state of -1. So each of those fluorine atoms has an oxidation state of -1. And that means oxygen, to give us an electrically neutral compound, must have an oxidation state of -2. If we look at BF3, boron trifluoride, it's also electrically neutral, so its charges need to add to 0. Once again, the fluoride is -1, or fluorine is -1, and therefore the boron has to have a +3 oxidation state, and that will give us a total of 0. Now if you're in my level 2 chemistry class or my level 3 chemistry class, you can do some extra practice on oxidation states and assigning them, and this is where you will find that information. Go to it and make sure you understand what you're doing with oxidation numbers. Have a good day.